Section 2.3, histograms. So we've worked on frequency distributions, and we've noticed that they're good for summarizing just our raw data into a table or form that lets us see trends. But it's also useful to show data using some type of visual tool. What we'll do here is convert information from a frequency distribution into a histogram. Now, a histogram is a graph that uses adjacent bars, no spaces or gaps, of equal width where the height's going to indicate the frequency of each class. Histograms can only be used to represent quantitative data. When we want to use this a similar type of graph to represent a qualitative data set, that's when we use a bar graph. Bar graphs and histograms are sometimes used interchangeably, but truly a histogram represents quantitative data, whereas a bar graph is going to represent qualitative data, and the bars don't touch. Let's just focus here on histograms. And here in example 1, we have a frequency distribution that represents the record high temperatures for each of the 50 states. Determine the class boundaries, construct a histogram. So the raw data has already been organized into a frequency distribution for us. But because our bars touch, we need to find the class boundaries to eliminate that gap between the classes. So remember, we go a little bit outside the class to find those class boundaries. So for 100, I'll use 99.5 and go up to 104.5. Notice that even though we shift a little bit for the class boundaries, it still has a width of 5 as the original class does. For the next class, we'll have 104.5 to 109.5, and then we'll fill in the remaining class boundaries in the same pattern. And finally, 134.5. Now when we go to construct a histogram, on our horizontal axis we'll put the temperatures, and we'll use the class boundaries at each tick mark. So 99.5, 104.5, and so on. 129.5, and we also need the ending class boundary, 134.5. Also, forgot to mention, on a horizontal axis, when you want to show that you're not starting at 0, we put this little symbol here to say there's space here, but we're not really starting at 0. We're jumping all the way down to these values. Okay, when you are constructing graphs, whether by hand or most likely in some type of computer program, make sure you label your axes so that the graph is easy to understand for the reader. So down here we'll label this axis as temperature. Now for our vertical axis, those will be the frequency, and since our highest frequency is 18, we'll go up to about 20. And it looks like we have enough tick marks to go by 2. So 2, 4, 6, 8. And I usually just like to have one more above the highest one. Okay, so let's draw our bars to represent the frequency within each class. So whether you're looking at 100 to 104, well, for the class 100 to 104, we're going to look at the class boundary 99.5 to 104.5. That has a frequency of 2. So we'll draw our bar from 99.5 over to 104.5 with a height of 2. And then the next one is 8. And so on a histogram, remember, our bars will touch. And that's so we can have that continuity between the classes. And here we jump to 18. And then 13. 13, so halfway in between here. And then 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 13, so halfway in betw 7, and 1, and 1 for our final 2 classes. Oh, and let's make sure, let's go back and label. For our vertical axis, we'll label this frequency. And for the overall title, we'll say something similar to what was given in the problem, record high temperatures. Of 50 states. So there's our histogram, and even though we saw that most states had a record high temperature somewhere between 110 and 114, we get a bigger picture with our histogram, noticing that things taper off from there, that there are actually more record high temperatures above 114 than below, and that very few states have a record temperature above 125. So just all of those things, that information is immediately available by having something visual to look at rather than just relying on the frequency distribution. So what we've done so far, both with our frequency distributions, we've tallied the data, counting how many data values fell within a certain class, and we use those counts on our histogram. Another calculation we can make is the relative frequency of each class. The relative frequency compares the frequency of each class against the size of the entire data set. So rather than just the count, we're actually going to have this proportion. The relative frequency usually will be expressed as a fraction, a decimal, or a percentage. So example 2, we're going to revisit the same data, the record high temperature from example 1, and this time we're going to find the relative frequency of each class. Let's go ahead and fill in the class boundary, since we already did that in step 1 or example 1. So here we had 99.5 to 104.5. Let's just fill those in. And then we have 129.5 to 134.5. So that's exactly the same as it was before. And our frequencies are here the same too. What we're going to do now is compare each frequency to the total. Well, we know that there are 50 states, or 50, our frequency should sum to 50. So for each frequency, I'm going to take it out of 50. So 2 out of 50 is 0.04, or 4%. 8 out of 50 equals 0.16, or 16%. 18 out of 50 would be 0.36, or 36%, and similar for the rest of our frequencies. We have 0.26, or 26%, 0.14, or 14%, and then these two will be the same, 0.02 or 2% for those last two classes. So here's another little check you can do. Just like before, we summed all of our frequencies, and they should add up to the total number of data values that was originally presented, in this case 50. But for the relative frequencies, your percentages or your decimals should add up to 1 or 100, or 100 or 1 respectively. So if you want to double check that, they should, and that just means you've gotten 100% of your data captured in the relative frequency. Now we're going to go ahead and graph a histogram. It's kind of missing from my directions here, but so again, we want to label our axis. So for the horizontal axis, we'll have the same labels on our axis. So starting at 99.5, 104.5, and so on. finishing with 134.5, and again we'll call this temperature. Now for our vertical axis, we're not talking about the frequencies this time, but the relative frequency. So we're going to label the percentages. And we don't have to go up to 100 since our highest frequency is only 36%. So let's go up to 40% or so. So we can do 5%, 10%. And the way I label it is not the only way to label it. If you'd rather label by 2s, that's okay. If you want to label by 10s, just make sure your graph is a good enough size so that a reader's easily able to read it. So I'm going by 5s, 5, 10, 15, 20%, and so on. And finishing up here with 45%. And we'll label our vertical axis as the relative frequency. And we're going to draw our bars just like before. So in that first class, we have 4%, so just a little bit under 5. And then 16%. A little bit above 15. And then 36%. %, 14%, and 2% for the last two classes. Okay. So, even though this is a relative frequency histogram, oh, and we need a title before we talk about that. Record high temperatures. Of the 50 states. Okay, so this is the relative frequency histogram. But do you notice anything between the shape of the regular histogram we did previously and the relative frequency histogram? What I hope you notice is they pretty much have the same shape. And if they were scaled the same, they would be exactly the same shape. So even though a relative frequency histogram is based on percentages, it will have the same shape as the histogram based on just the regular frequencies.